Okay, we are from Sirkulasi University and National Weather Service of Indonesia. Would like to present and perhaps be preceded by the discussions of El Nino phenomenon in 2015 in terms of how STEM of El Nino is developed to facilitate the teacher training and educations, mostly encouraging our young generations, our young scientists, and how El Nino impact on the rainfall, emphasizing on the case study of Aceh Besar's regencies rainfall during El Nino year. Me, I'm Yopi Ilhamshah on behalf of the team originated from Sirkulasi University and BMKG. Would like to present the STEM conference topic entitled El Nino 2015 STEM Educations and the Impact on Rainfall in Aceh Besar Regency, Aceh Province. Okay, let's begin our short talks with the introductions of what causes El Nino and how we are affected by El Nino. El Nino actually is not a storm, but rather a climate phenomena in the Pacific Ocean. Here we can see the Pacific Ocean located between South America in the east and Indonesian archipelago, as well as Australian continent in the west. During El Nino, the surface ocean's temperature warms up, leading to complex weather patterns. It is noticed in the South America, during the 19th century, South American fishermen described warmer ocean surface during Christmas time. It was coined the name El Nino, Spanish translation for blessed child. What happened in this period during El Nino? When sea surface temperature in the equatorial Pacific Ocean rise to 0.5 degrees Celsius, over their historic average for 3 consecutive months. It means the sea surface temperature rise above normal of their climatic conditions for 3 consecutive months. And once atmospheric conditions and rainfall patterns shift accordingly, scientists, we as meteorologists will declare that El Nino is occurring. El Nino even takes place about 2 to 7 years. Normal east to west trade winds over the Pacific Oceans to weaken. So we can see here during El Nino, this is a normal condition, and this is El Nino. During El Nino, trade wind is weakening and is reversing. So if normal conditions, the wind trade as well as the Walker fluctuations, the vertical layer, a blow from east to west, or it is known as easterly trade wind. During El Nino, when El Nino happened, it reversed. So if it is not in normal conditions, trade wind blow from east to west. During El Nino, it reversed. It flows from west to east. During El Nino, as trade wind is weakening and reversed, normal east to west trade wind over the Pacific Oceans is weakening. As I mentioned earlier, that during El Nino, this trade wind that bring water mass from east to west, it is reversed, and weakening, and water mass will come from west to east. So here the warm surface temperature is moving toward south, and it might lead to warm water in the South American. Meanwhile, in the Indonesian archipelago, where the cold water from bottom is rising, it might lead to cold water in the surface. And because of these conditions, warm water will contribute to high evaporations that might trigger storms, that will followed by heavy precipitation, heavy rainfall that might cause floods in South America. Meanwhile, in the Indonesian archipelago, because of cold water, so less evaporation in the ocean, it might contribute to clear sky over the Indonesian archipelago. So we used to find forest fire during El Nino because of high temperature in the surface during El Nino in the Indonesian archipelago. Okay, this is the conditions during normal year, and this is the conditions during El Nino. So we can see the differences between these two conditions, okay? And this slide will talk about the normal year cross sections and El Nino year cross section. As I mentioned earlier, that the trade winds are coming from east to west during normal, and it circulated in the vertical line as Walker circulations. Yeah. Here we can see the cross sections during normal year. Yeah. Thermocline is deeper in the ocean's continent, Indonesian maritime continent, while in the South America, thermocline is shallower. Yeah. So we can see these two ocean conditions. Yeah. So during normal year, warm water in the ocean, in the Indonesian archipelago, cold water, cold ocean water in South America. Because of this, in South America, they used to go to the sea, to catch fish because of upwelling emergence during normal year. But during El Nino, in the El Nino years, in South America, the fishermen are not easy to find the fish in the ocean because of upwelling is decreasing. Here we can see that in South America, the thermocline is thicker, and warm ocean's water is dominated in the coast of South America. Meanwhile, in the Indonesian maritime continent, thermocline is shallower, and it is dominated by cold ocean's water that might lead to clear sky above Indonesian's maritime continent that might contribute to warm surface, and we could easily find forest fire during El Nino. This is the ocean conditions between normal and El Nino year, okay? Here, in this research, we set up STEM educations as well as to investigate the reduction of rainfall in Aceh Besar Regency. So for STEM educations, we provide fan, plastic container. Here we fill plastic container with hot and cold water. So to distinguish between hot and cold water, we put food coloring. For hot water, we identified hot water by giving red food coloring, and for cold water, we put a green food coloring. So it is very simple to conduct, to mimic the El Nino conditions. So we only provide plastic container fan, hot water and cold water. We could easily find it. For hot water, of course, we have to build the water, and cold water, we bring cold water from the fridge, and we use food coloring to distinguish between these two water conditions. For rainfall data, we have 8 rainfall stations around Aceh Besar, and we will correlate with sea surface temperature anomaly that might detect the El Nino conditions using Nino 3.4 from the Pacific Oceans. Yeah, so we could identify El Nino by using this index, Nino 3.4. The data is obtained from HDSST. I mean, one of the remote sensing technique that we derive from satellite. Okay, so for rainfall anomaly, we could find it from the deviation between 2015 and 2017. Okay, so it is very simple, right? For STEM educations, we only need this and to investigate the reductions of rainfall during El Nino, because if El Nino is strengthened in Indonesian archipelago, so it might affect Aceh as well, in the far west of Indonesian maritime continent. Yeah. Even though sometimes we do not suffer from El Nino because of our location that is located in far west, but in 2015, yeah, we suffer from El Nino because the El Nino was one of the strongest signal at the time of El Nino. So this is the cycle of El Nino showed here from 1816 to 2020. Yeah, here we can see the top 1, 2, 3, 4, the top 6 of El Nino signal. Here we can see that El Nino 2015 was the strongest, and also even was the strongest ever compared to other signal of El Nino. For instance, in the 1997 to 1998, when we have El Nino also. Even in 1997 and 1998, the world experienced the biggest El Nino in the record history before 2015. Yeah, some blame that El Nino caused massive death and damage at the time. Yeah. It is noticed that in Central Asia, the temperature reached 108 degrees Fahrenheit. There was also record flooding in Peru and the tornadoes in US. In Indonesia, we must remember of forest fire not only in Indonesia but across Southeast Asia at the time, where people in consequence suffer from a respiratory disease. Yeah. So scientists are now better able to predict if and when El Nino event will take place. This helps communities better prepared for the changes and weather pattern better adapt to its repercussions. Yeah, and now we could we could conduct mitigation if El Nino is coming. So to know whether El Nino is coming or not, we could see from this cycle if it is claimed that the anomaly of sea surface temperature is ranging from 1 to 2. Yeah, El Nino is claimed to be in moderate status. While if the anomaly of sea surface temperature here is above 2 degrees centigrade, it means the strong El Nino, stronger El Nino will come. Okay. If the anomaly of sea surface temperature range between 0 to 1 or 0 to 0.5 here, as you can see, 0 to 0.5, it is classified as normal climatic conditions. So we do not find El Nino, we do not find La Nina, but if the anomaly of a sea surface temperature ranging between 0.5 to 1 degree centigrade, 1 degree Celsius, it means we might suffer from weak El Nino. But if the anomaly is above 1 degree, even if above 2 degrees centigrade, it means the moderate and even stronger El Nino is about to come. So here we can see that the cycle of El Nino here between 1916 to 1980, we also have El Nino here, and between 1980 to 2000, here we have one of the strongest El Nino at the time, that is 1997 and 1998 El Nino that not only we in Indonesia, but across the continent, across the globe, on Earth, suffer from El Nino conditions. In Indonesia, we suffer from drought, yeah, forest fire, yeah, because of prolonged El Nino conditions. In South America, in US, yeah, they suffer from heavy rainfall. They might cause floods, flash flood, yeah, tornadoes, hailstone, sometimes like biggest tropical cyclone in the oceans in the Atlantic Ocean. So El Nino is global teleconnections that might suffer from that we could suffer from El Nino across the continent, across the globe. Okay. So here we set up El Nino STEM. Yeah. It is very easy to conduct, and we filled the plastic container with water, and then we mixed with cold air, represented by green color, and warm water is represented by red color. So here you can see that the green color, it means that the cold water is sinking because of density, high density. So the cold water, because of a difference in density, will take place in the bottom of the plastic container here, and warm water, because of light in density, yeah, so will take place in the upper of a cold water here. So in conclusions, the cold water is sinking, while warm water, identified by red color, is rising. So here we can see during El Nino, if you put fan above the cold water, so this is plastic container for coloring between red and green that might identify cold and hot water, and above the cold water we put fan, to generate wind. So here we generate water circulations and the reversal of trade wind. So we could see the raisings of cold water from bottom that might trigger the raising of water mass from bottom. So if the water mass from bottom is rising, it means that we might experience upwelling during El Nino year in Indonesian maritime continent. On the contrary, we must suffer from drought because of clear sky, because of less evaporation. Less evaporation might have less convective cloud. Because of less of convective cloud, so we do not have rainfall during El Nino. So that's why we might see a blue sky on the surface in Indonesia. While in South America here, you can see the thermocline is thicker in South America, and warm water is dominated, is pushed, warm water because of light intensity. Yeah. It will push to the coast of South America. So here in South America, we find warm water with deeper thermoclines. So because of warm water, the evaporation is higher. Because of higher evaporation, you might have heavy rainfall because of cumulonimbus clouds development that is precedes by higher evaporations. That's why we have two different kind of conditions during El Nino. In Indonesia, clear sky. On the contrary, in the East Pacific, you might have thick cumulonimbus clouds, followed by rainfall. And during El Nino, here is dry. Meanwhile, in South America, they encounter with heavy rainfall and will trigger floods. Yeah. Okay. Here we can see during El Nino that the trade wind is reversed, as well as the water circulation in the vertical layer. So here in Indonesia, we have shallow thermocline. Because of a shallow thermocline and the risings of water mass from bottom. Here we have cold pool. Because of cold pool, no evaporation. So we have no convective clouds here. So what we face is that the hot condition in the surface. Meanwhile, in the South America, because of warm water is pushing towards east, so warm water is located in near coast of South America. Because of warm water, the evaporation is higher. Evaporations might lead to convective clouds that will proceed by rainfall. That's why in South America during El Nino, they suffer from clouds, while here in Indonesia we suffer from drought. On the other hand, in the oceans, because of the risings of water mass from cold water mass from bottom, the upwelling emerges. So it is, if the cold water mass is rising and the upwelling happen, of course, the fish will love this kind of conditions. Because the water is not too hot, and the rising of water mass will bring nutrients from the bottom that feed the animal, that feed the fish. That's why here during El Nino, we would have abundance of fisheries productivity because of the emergence of the upwelling. Okay, here we can see that, even though we will suffer from less rainfall, less rain during El Nino, but as the water mass is rising from the bottom, we might have upwelling in the ocean. So because of upwelling, we will find abundance of fish in the oceans. While in on land, we can see that here, you can see that in Aceh Besar again, the peak of rainy season might only have less rainfall. Because of less rainfall, we suffer from droughts. That's why we have to mitigate this kind of conditions before El Nino is about to come. So we must build proper water infrastructures to preserve the water, so that if El Nino is coming and we suffer from drought, so we still have water to drink, water to watering the plantation, watering the paddy field. Okay, so here we have significant correlations between rainfall and also Nino 3.4 that representing the El Nino condition. So what we could find here is that rainfall is reducing in Aceh Besar again. This is Banda Aceh where we live. On the other hand, in the oceans, we would find upwelling that might contribute to the abundance of fisheries productivity in the oceans. For conclusions, STEM educations of El Nino is feasible to conduct, and we still need to improve with various experiments, as what we showed just now, that it's very simple. It just mix hot and cold water, and you could see difference of density and where the cold water is sinking and take place in the bottom of the container, while the warm water, because of less density, it will take place in the upper layer. So because of density differences, actually. And on land, as I said earlier, that we suffer from drought. Because of drought, we crop and plantations fail and might treat our food security. While in the oceans, sorry, it is wrong. It should be in the oceans, upwelling emerge, and it might lead to fisheries productivity. Therefore, even though in the land we would suffer from crop failure, but in the ocean we will have good fisheries productivity because of the emergence of upwelling due to the rising of cold water that might bring marine rich nutrient to the surface that feed the fish. And the ocean condition is not so hot, so the fish would love to swim in the upper layer. So the fishermen will easily catch fish during El Nino. But of course, because it might lead to severe drought in land, of course, we need to act. We need to perform a proper mitigation. We have to build dam, reservoir, long storage here, as well as the forest conservation to preserve the water before El Nino is about to come, okay? And we could maintain, if we optimize this kind of conditions, yeah, even though on land we suffer from droughts, yeah, we could maintain our national food security. Yeah. Now, there is a news where La Nina is about to come. What is La Nina actually? The mechanisms of La Nina is almost the same as normal year conditions. Yeah. Here, normal year condition. When La Nina come, yeah, the trade wind is stronger than normal. Yeah. So La Nina year actually is all the same as normal year, but Walker circulation, the Walker circulations that might lead to trade wind in the surface, yeah, is moving faster because of the conditions. Yeah, trade wind on the surface blow harder, resulting in a mass of warm water being pushed and gathering in the ocean's water. So La Nina year is almost exactly the same as normal year, but the trade wind is moving faster than usual. Trade wind is moving faster than normal conditions. That might trigger warm ocean's water to push to Indonesia's maritime continent. Here in Indonesian maritime continent, we have during La Nina we have a deeper, more deep of a thermocline, and here we have cool, and not cool, we have a warm water in the surface, yeah, to the thermocline layer, yeah, because of a warm pool, yeah. Of course, it might trigger heavy precipitations because of higher evaporation from the oceans. Yeah. That's why during La Nina, yeah, La Nina will about to come within this 1 month. Yeah, La Nina will about to come to Indonesia, and we will have heavy rainfall. We will have higher rainfall than normal, yeah, at about 40%, as predicted by BMKG. Okay, so La Nina is almost exactly the same as normal year cross sections, except the trade wind is moving faster in the ocean that will push warm ocean's water to Indonesian maritime continent. That's why during La Nina we will have higher rainfall than normal. Yeah. There might trigger floods everywhere in Indonesia. But yeah, we pray Aceh, because of Aceh's location is located far west from the Indonesian's maritime continent. We pray that we might not have floods during La Nina year. Okay, so this what La Nina look like, and of course there is a lag time when water circulation and trade wind start to strengthen from normal. Usually it takes 5 to 7 months after El Nino. Yeah. It gets stronger during the rainy season in Indonesia during December, January, and February. That's why in Java, in East Indonesia, they suffer from heavy rainfall, even floods. Yeah. So we pray this might happen in Aceh because of our location that is located far in the west of Indonesia. Yeah? This is why, yeah, central and eastern Indonesia rainfall is higher above normal. It might reach 40%. But in the western part of Indonesia, we hope we do not suffer from La Nina from higher rainfall conditions during La Nina year. Okay, thank you for your attentions, and I truly appreciate your attentions of this short talk. Hopefully, we could have another lecture about climatic conditions in Indonesia's region. So, thank you very much for watching. Do not forget to click and subscribe this channel. Okay.